Hello friends. So I'm gonna be very honest with you. The question we are going to do today is related to bit manipulation and binary manipulation. Basically, these are not the most popular technical interview questions, and if you want, you can skip this video entirely, even during your technical interview preparation. I personally created these questions because I wanted to learn them, and maybe for anyone like me who wants to know that what these questions mean, because there is always going to be some benefit on learning a new skill. But apart from that, to be very honest, you can also skip this one. So it's up to you. I just put it out there, and let me know if you find it useful. But anyways, let's see the questions.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code medium problem, sum of two integers. So let's understand the problem statement. Basically, we are given two elements a and b, and we need to return the sum of two integers without using the plus or minus operator. And the problem statement is really simple. Basically, we are given two values a and b, and we need to return the sum of a plus b equals to in this case 3, but without using the plus operator. So let's see how can we do that. We are going to use two-bit manipulation operators. First one is something called XOR or exclusive OR, and second one is AND. So let me show you what each of them does and what does it mean. So we will consider a table like this where we are given the values of A and B and the value of A XOR B. Now these are binary elements, so we can the only possible values we can have for A and B is 0 and 1, and we can have four possibilities. Either both are 0 0, 0 1, 1 0, or 1 1. And the answer for A XOR B would be 0 0 is 0, 0 1 would become 1, 1 0 would also become 1, and if both are 1, we would again consider it as 0. So this is just something that we keep in our mind and we will use it further down in our equation. Now let's see what would be the table for A and B. Now as the name suggests, A and B, we only set the value as 1 if both entries are 1. Otherwise, if there is any single 0 present, we we get the answer of A and B as 0. And now let's see how can we use these two operators to find the sum of any two values for our given problem. So suppose we are given two values like this, A equals to 5 and B equals to 3. So the sum of A plus B, as we know, is 8. And let's see how these values are represented in binary. So A would be represented as 1 0 1, and B would be represented as 0 1 1, because in binary operator the value of any element is actually done as 2 of 0, 2 of 1, 2 of 2. So this becomes 4 and this becomes 1, so 4 plus 1 equals to 5, and same over here, this is 2 and this is 1, so 2 plus 1 equals to 3. Okay, now let's try to do a summation of these two values. So 1 plus 1, we cannot do 2 over here because this is a binary representation. So we will do as 0 and we would have 1 as carry that we carry on towards the left value, and again we get 1 plus 1. So again the value becomes 0 and we have a carry that we need to consider on the left side. If we take the carry again, we get the value 0 and we will have a carry over here, and we don't have any value over here, so we can just consider this as 0 0. So with the carry the value becomes 1, and if we do the if we find the binary value for this one, this is actually 2 of 0, 2 of 1, 2 of 2, and 2 of the power 3. So the value 2 of the power 3 is actually 8, and which is our answer. So if we do the simple addition of binary values, we can also get the answer as 8. But the problem over here is that we should not be using the plus operator, so we cannot just simply add these two values. So the longer route we can take is we can try to do A X or B first, and then we would do A and B, and we would move the values to one point left. This is simply what we are going to do for the given elements until the point where we find that the values of A and B uh, as 0. So this is the broader idea of our algorithm, and let's see what I mean by that. So the value of current A is 1, 0, 1, and B is 0, 1, 1. So let's try to do A, X or B. This is the symbol for X or in computer language. So we will simply use this one, and let's see what the value becomes. So we know that 1, 1 is 0, 0, 1 is 1, and 1, 0 is also 1. Now we need to do the operation of A and B. We are doing this operation to find the carry value with A and B values. And because we are finding the carry values, we know that whenever we have a carry at any location, we need to move it one step on the left side. So we will again use the same logic that we will use A and B to find the carry value, and we would move it one step on the left side. So let's see what the values would be for A and B. So basically we have 1, 1 over here. So that value would become 1. And notice that we are writing 1 over here and not over here because we are shifting the element on one step towards the left side. So we have 1, 1 as 1. Next values we have is 1, 0, sorry, 0, 1, and we set it up as 0, and again we have 1, 0, so again we set it up as 0, and because we don't have any value over here, we shifted one value on the left. We can consider the value as 0 over here. Now we have calculated the results for A, X or B, and A and B, and we have moved them towards the one step on the left. In our algorithm, this would become our new A and this would become our new B, and we would have a loop that until we get a value of B that is not 0, we would continue with this operation, and let's see where we will get. So now the values for A and B would be A would become 1, 1, 0, and B would become 0, 0, 1, 0. And now let's repeat the operations again. So first we will do A, X or B, which gives us 0, 1, 1 becomes 0, and we will have a carry, but we will consider it later. 1, 0 becomes 1, and 0 becomes 0. Now let's do A and B and shift it to 1 bit on the left side. And because we have to move it 1 bit on the left side, we will start it over here. So 0, so 0, 0 becomes 0, 1, 1 becomes 1, 1, 0 becomes 0, and 0 becomes 0. And because we don't have any value on the rightmost part, we will consider it as 0. So again, we will assign the values as A and as B. And we notice that B is still not 0. So we will continue with our operations and we will continue with our loop. So again, let's repeat the same operation. So A mod B becomes 0, 0, again 0, again 0, and 0. So all zeros we are getting as A XOR B. And now A and B shifted one element on the left side becomes, we start one element on the one element from the rightmost element. So 0, again 0 for these two, 1 1 becomes 1, 0 0 again becomes 0, and we have one blank element on the rightmost bit, so we can consider it as 0. This becomes our new A and this becomes our new B. We notice that B is still not 0, so let's repeat the operation. And now we are going to do A XOR B equals to 0 0 0 1 0, and A and B shifted one bit on the left side. So notice that on this A value, we don't have any ones, which means that under no circumstances we can have this A and B where we get one answer, because A is always 0. So same thing applies over here, and basically this value would become all zeros, 0 0 0 0 0. And now again we assign our values. So this becomes A and this becomes B. And notice that in this scenario, B is completely 0. So we can break out of the loop. And when we break out of the loop, we can simply return the value of A. So the value of A we have found in this scenario is 0 1 0 0 0. And this is a binary number. If we were to convert it to decimal value, we can understand this as 2 of 0, 2 of 1, 2 of 2, 2 of 3, 2 raised to 3, and 2 raised to 4. So all of these values are 0, so we don't consider them. This one is 2 cube, which is 8. So we can return A as 8, and this would be our final answer. And if we see the original two values in our request, basically we had the two integers A equals to 5 and 3, and we get our answer perfectly defined over here, and we reach to this answer without using the plus operator. So this would be our solution. And now let's calculate the time complexity for the given problem. So basically, if we see the given input over here, we have a constraint that all the values are between negative 1000 and positive 1000, which means that essentially we can calculate the time in a constant time complexity, big O of 1. We don't need to calculate anything additionally, because overall the input is quite small and we can simply do it constantly. And also the space complexity would be big O of 1, because we are not using any additional space. We are just using a couple of variables to store just few values. So this is a really ideal approach. And I know that a lot of people don't like to have bit manipulation, and they simply ignore it or they hate it. And most of the times companies don't tend to ask this kind of questions, but we are preparing for FAANG. We are not preparing for some random company. And if you want a dream job, why would you compromise? So I would just suggest that go over it. It might take you like 2 3 hours to go through all the bit manipulation questions and understand the concepts. But once you are done with that, you will have an extra edge in the interview. So I would highly recommend not to skip anything and not to put anything on the chance. I will, and now let's move on to the coding, and we are going to implement the solution. So if our intention is to just submit it for the sake of submitting it, and have it accepted by lead code, we can simply write one line of code. We can simply return A plus B, and apparently it works. Yeah, but this is not what we want. So we would be writing the complete solution that we would use in an actual interview. So first of all, we will create a while loop to see if the value of carry is actually 0 or not, and we are going to store the value of carry in the B element. So while B is not equal to 0, Now we will create a variable to store the value of A, X or B. Let's name it temp. And now we will calculate carry as well. We will do A and B and shift it to one place left. Shift it to one bit on the left side. And now we simply store the value of temp in A. So A becomes our temp. And as mentioned earlier, we will store the carry in B. And yeah, that's pretty much it. Once this loop runs, our solution should be stored in A. So let's return A. Let's try to run our code. Looks like our solution is working. Let's try submitting it. And yeah, our solution works pretty neatly. It's apparently 100% faster than all other solutions, but actually this is not true. All other solutions are also 100% faster because the runtime is in constant time. So hope you liked the video, and let me know in the comments if you want me to update anything in the video. Our aim is to clear FAANG interviews. I'm making these videos so I can practice for myself, and also I can spread the knowledge I have gained to other like-minded people. And yeah, see you soon. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, number of one bits. And this is a bit manipulation problem. I know a lot of people don't like it, but it's really simple to understand. So the problem statement is pretty simple. We just need to check that in any given integer, if we represent it in binary form, how many times the one value is being repeated. So in this given example, we are given a number like this, n is equal to 1011, which is the binary representation of the decimal value 11. That we need to check that how many times this one is repeated in the given integer, and clearly over here we can see that the one is being repeated three times, and which is the answer of this problem. And notice that the number is represented quite long because it is showing that all the 32 bits of any integer, and all the input types would be of 32 bit, and we need to find that how many times one exists. So the first approach we are going to take is quite simple, and we are going to use a binary operator AND. Now let me show the table for AND binary operator for any given two values. We can have four possible combinations, and A and B means if the value of A and B both are 1, in only that scenario we are going to consider the value of A and B as 1. Otherwise, if there exists any single 0 or both values are 0, we would just simply put the values as 0. Using this logic, we can solve this problem really fast, and the most basic approach is we would simply run a loop 32 times, and every single time we are going to compare each element with 1 and see that if we AND the value that exists at any given location with our value 1, and if the answer is 1, we do counter plus, and after running the loop for 32 all the 32 bits, we would just simply return the value of our counter. Let me show you by an example what I'm trying to say. Suppose the input we have is 13. If we represent it in binary, it would look like, and we would have 28 zeros and the prefix. Now we will create a value, just any random variable, and we would give it as value number 1, and we will run a loop from 0 to 32, and inside the loop, for every single value, we would compare that whether this one, we would compare it with the rightmost element in our given input array, and we would do an AND operation between these two values. And we would have a counter that we initially set it up as 0, and whenever we find that the answer of these two AND variables is actually 1, we would simply increase the counter. So for the for the rightmost position, we would increase the value of our counter, so counter would become 1. And after we are done with this condition, we would simply do a left shift for this random operator in the for the given input. So now 1 would be shifted one position to the left, and we would again do the same operation. So this time we will do an AND operation between this 0 and 1, and the value of AND operation would be 0. So we won't update the counter, and again we would do a left shift for this one element. And again we would do an AND operation. The value we would get is 1, which means we need to update our counter. So counter becomes 2. And again we would shift our element. We do an AND operation again the value still remains 1, so we update our counter again, and we update the counter to 3, and then we would subsequently update the value of this random character to 1 bit to the left. And now notice that all the remaining bits are 0, so the AND operation will always equal to 0, so we won't update the count, and at the end of the loop we can simply return whatever value of count we found as our answer. Now this approach works perfectly fine, and this approach actually runs in big O of one time, because we only have to run the loop 32 times, which is a minimal amount of work that we have to do, and the answer would always be constant. So this is in itself pretty neat solution, but let's see if we can go one step further and we can reduce this loop counter time to less than 32. In order for us to understand the optimal solution, let's first take an example. So, say we are given a value n equals to 36. Now let's represent this value in binary, because we know that binary works like 2 to the power 5. And if we do the summation of these values in decimal terms, uh, this would become 4 and this would become 32. So 32 plus 4 becomes 36. Now, the intuition behind this solution is that if we take one value lesser than 36, let's say 35, and if we represent this value in binary terms, the binary representation looks like, and notice that the first one that we encountered on our original input, the one value lesser than that has the exact opposite in terms of number of ones up until this point. That if we do a AND operation between these two values, the value we would get is like this. So notice that this one has already disappeared in the AND result of these two values. And if we repeat the same process, so now this value that we got in binary, the value is actually 32. And again, if we repeat this same operation, that we do an AND between the number by itself with one value lesser than that, we would gain a result like, so first let's represent the value number 31 in binary. And now if we do an AND operation between these two values, the answer we would get is all zeros, which exactly means that we would only run the loop the number of times 1 we have in our original given input, because over here we only had 2 1 in the input. So during the first iteration of our loop we got rid of this first one, and we can see it over here. And during the second AND operation we got rid of the second one as well, and we got the answer as all zeros. So at the beginning, if we create a variable count and we originally set it up to 0, and every time in the given loop, if we just go through the loop and the value of the value of current n is not equal to 0, we just simply increase the value of count to 1. So which means that during this first iteration the value of count would be 1, and during the second iteration the value of count would be 2. And after that we found that the value of n is actually equal to 0. So we can simply break out of the loop, and when we break out of the loop we would return whatever the value of count we had found. And in this case the value of count we found is actually 2. And this solution would work perfectly fine, and this would be our optimal solution. The time complexity for this solution is also big O of 1, which is a constant time. But the thing is, the number of loop iterations that we have to go through would only be equivalent to whatever the value of 1 we are given in the original input array, and we don't have to run the loop 32 times like the previous solution. So we are actually in our constant time solution, we are also saving a lot of time, and this would be the fastest solution we can reach into. And in terms of space complexity, we are not using any additional space, so complexity would also be constant time. And and now let's move on to coding. Thank you.
So first of all, we will create a variable for count and set it up to 0. Now we simply run a loop. We will run this loop till the number is not equal to 0. And with every iteration, we will increase the value of count, and we will simply do n equal to n and n minus 1. At the end of the loop, we just return count. Looks like our solution is working. Let's try to submit the code. And yeah, submission works as expected. It's pretty efficient and neat. And let me know what do you think about this video. And if you have any more suggestions, feel free to reach out to me in the comments, and I can address them. Thank you. Bye bye.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, counting bits, which in my opinion should be a lead code medium problem. Let's understand the problem statement. So basically we are given an integer n as input, and we need to return an array such that it defines that for every single value from the range of 0 all the way to whatever given n is, how many times the value 1 is repeated in its binary formation. So let's try to understand this with an example. Suppose our given input is 3. So the range from 0 to n would be 0, 1, 2, 3. And if we represent these values in binary, the representation would look like 0, 0, 1, 1, 0, 1, 1. And we need to return an answer array such which is of n plus 1 size, such that it represents that for every single value from 0 to n, how many times this bit 1 is being repeated. So now for the 0th position, we don't have any ones, so we enter the value 0. For the first position, we have one bit, so we enter as 1. Same goes for the second value, so we again add 1. And for the third value, we have two ones, so in the answer we provide as 2. And this would be our array that we would return as our answer. So let's see what are the different approaches we can take. So the first approach we can take over here is of one of the previous lead code questions that we have already solved, a number of 1 bits. And let me give you an overview of the solution we had achieved previously. So if we are given any number n is equal to 5, and if we represent it in binary, it becomes 101. And if we want to find that how many number of 1 exist in the given input, we would simply do an AND operation between the number and its one value lesser than the number of itself. So one value lesser over here would be 4, and if we represent it in binary, it becomes like this. And if we do an AND operation between these two values, the answer we get is 0, 0, 1. And this would be our first iteration. Now we would repeat the same process. So now again the number we found after doing this AND is 4, and we would do an AND operation with one value lesser than 4. So 3 would become 0, 1, 1. And if we do an AND operation between these two values, the answer we get is 0, 0, 0. And the moment we get 0 answer, we break out of the loop. And at the beginning of our loop, we would create a variable count, and only initially it would be set up to 0, and with every iteration we would increase the value of count. So during this iteration the value of count would become 1, and during this iteration the value of count would become 2, and at the end when we find that the number is actually 0, we would return whatever value of count we found as the number of ones that exist in our given input. So we found that in our given input 5, it has two number of ones. We can repeat the same formula for the given input, and let me show you how we can do it. Suppose the input we are given n is equal to 4. We need to create an array from 0 to 4, and we need to calculate that for every single value how many number of ones are present in that given input. So the answer array would be, we would need to provide that how many number of ones exist. So we can create a function called count1, and for and we can run a loop over all these values, and every single time we would pass on whatever the current value we are trying to find the count for. And whenever we run this function that uses this logic, the one that we just discussed, then we would be able to find that how many number of one exist for every single given element. And when we get the answer back, we can just simply fill in our array and return this as answer. This solution would work perfectly fine, and the time complexity for this solution would be n, because we will have to run a loop towards the entire towards all the given values, and we for every single value we would have to run this operation, count the number of ones, and this loop runs for the time being of number of ones that exist in any given input. So over here for number 5, there exist two ones, so we will have to run the loop twice. Suppose if we are given any n is equal to like this, then the loop will run 6 times. So we can say that this solution basically works in the time complexity of big O of n times log n, because in order to find this count, because in order to find number of ones, we would have to run multiple loop, we will have to run multiple iterations in this count one solution. So this is in itself a pretty efficient solution, but we need to see that if we can find a better approach, and can we have an optimal solution. We can have optimal solution. Let me show you how we can achieve that. Now, in order to find the optimal solution, first let's try to understand that how the logic actually works if we want to find the number of ones in any given element. So the operation we are doing is basically we take n and n minus 1, and then we do a counter plus plus. So we can represent it in a different manner. So first let's try to understand that suppose n is equal to 9. The actual calculation we are doing is n minus 1. We are doing an AND. So basically this means that after the AND operation we get the value as, and the value this comes up as 8, and we do an a plus 1. So keeping this in mind, and again, if we do it for the value number 8, what we are actually going to do is we are going to, now our n is 8, so we will do n minus 1 as 7, and the answer is 0. So basically our n is 0 at this moment, and we again do plus 1 in our counter. So if we write this in other way, we can write it as that answer for the number 9 is actually whatever the answer we found for 9 and 8 plus 1. And if we go down one step further, the answer for actually this 9 and 8 is actually the answer for whatever the value of 8 we found plus 1. We can write this exact same formation as this. And if we try to calculate the value for this uh, a of 8, actually we can write it as a of 8 and 7 plus 1 for this particular value. And this actually becomes a of 0 plus 1. And we know that a of 0 is actually 0 plus 1 is 1. And this 1 is actually the value of a of 8. Now, if we replace this a of 8 over here, we can say that the a of 9 is actually a of 9 and 8 plus 1. And we know that the value of a of 9 and 8 is actually a of 8 plus 1. And we know that the value of a of 8 is actually this 1. So we can say 1 plus 1, and we can come to the conclusion that the number of ones present in value number 9 is actually 2, and which is what we are given over here, and which is what we know. And basically what we have done is we have taken this input for any single individual element, and we have actually computed the results, we have actually stored the results, and based on those results we are able to find the future values. And basically we are applying dynamic programming. We can simply calculate the solution for our entire array in just big O of n time. Let's take another example to make things more clear. Suppose our given input is equal to 6. So if we want to find the answer for 6 using the logic we found over here, we can consider this as answer for whatever we find for 6 and 5 plus 1, and the answer for 6 and 5 is actually this equals to 4. So we can write this as answer for whatever the value of 4 we got plus 1, because this turns out to be 4. And subsequently, if we calculate the value for 4, we can break it down further as, so we can write this as answer for 4 and 3 plus 1 for this portion, and plus 1 for this one. The answer for 4 and 3 is actually n is equal to 0. So we get answer of 0 plus 1 plus 1. This would be our final answer for our answer for value number 6. So see over here that we have, when we get to value number 6, we would have already calculated all the values from 0 to 5. And we, since we have the answer for from 0 to 5, we will use those answers to quickly determine the answer for value number 6. And this logic enables us to get our solution in just single iteration, and this would be a better time complexity than our previously suggested algorithm. And in terms of space complexity, anyways, we have to create an answer array in order to return it as a part of the answer because it is given as requirement uh, for the given input, that we are not using any additional space, and we can just use the same array to represent the answer and also use it as our dynamic programming solution. So space complexity would also be a big O of 1. And this is a really ideal approach. And let's move on towards the coding.
So first of all, we will create an answer array and we would give it the size of n plus 1. And now we initialize the answer array of 0th value to 0. And now we just need to run a for loop. We'll start the loop from I is equal to 1 because we already calculated the value for 0. And we will run it while I is less than or equal to n. And we just have to write one line of solution, that if our answer of current I is actually equal to answer of I and I minus 1, and whatever the result of this is, we just add 1 to it. And yeah, basically after the loop we should have our answer array completely filled up and we can simply return it. So let's try to run our code. Oh, we forgot to initialize the value. Yeah, looks like our solution is working. Let's submit this. Our submission works pretty fast compared to a lot of other submissions, and as we can see that this is just a couple of lines of code that is really doing the trick. So though this is really simple to see, but in order to come up to this answer requires very strong knowledge of dynamic programming. Hope you like the explanation and the videos. Let me know if you want me to do anything else with the videos, or provide me any suggestions on how can I improve.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, missing number, and let's understand the problem statement. Basically, we are given an array of numbers containing n distinct numbers in the range of 0 to n, and we need to return that there is one number that is missing, and we need to return the missing number. So if we take the first example, the range we are given is 0, 1, 2, and 3. But when we see the actual input of nums, in the input we only have 3, 0, and 1. That if we start cancelling out the numbers that are present in nums and also present in our given range, 0 can be cancelled out, 1 can be cancelled out, and 3 also can be cancelled out. But the value number 2 is present in our range but not in the given input. So we would simply return the value 2 as not being present, and 2 being the missing number. So there can be multiple approaches on how we can solve this problem. Okay, and we would try to Keep in mind with this follow-up as well, and we will try to solve this problem in big O of 1 space complexity and big O of n runtime complexity. So the first two trivial approaches we have in our mind is first one, that if we sort the input array, we can clearly we can solve this problem easily. But the issue with the sorting approach would be that the runtime complexity would be n log n, because we need to do sorting first, and that takes n log n time. Second approach is to use a hash set, and we would keep on storing all the values of nums input in the hash set, and then we would iterate with the range loop and go over hash set to see if the value exists in the hash set of not, or not. And eventually we would find a value that exists in range but does not exist in hash set, and that would be our solution. And the good thing about hash set approach is that runtime complexity would be big O of n, and but the issue comes for the space complexity, and the space complexity for this approach would also be big O of n, which is not what we want. So let's see what would be the optimal solution, and I would be showing two optimal solutions in this coding problem. So our first optimal approach is actually pretty simple. Basically, we are given two items. First one is range, that is from 0 all the way up to n. And second one is nums input array, where the values are 0 all the way up to n, but one of the value is missing, and we need to find this missing value. So the most simple approach to do is we run a for loop on this range parameter, and for every single value in the given input from 0 all the way up to n, we simply do an addition of all the values. We store the result of all the elements in the range in a parameter called range sum, and we would find some value over here. And again, we repeat the same process, but this time for nums. So we do the sum of all the elements in the num with another for loop. We store the result of sum in a new parameter called num sum. You can put any name. This is just randomly something for taking the name. And then when we do a difference between range sum and this number sum, the difference would actually be the missing number. And this way we would be able to find the solution pretty quickly. Let's take it by a quick example. So clearly we can see that this value 1 is missing. So the sum of all the elements over here would be 10, and the sum of all the elements over here would be 9. So if we simply do 10 minus 9, we would find the value 1, which is the missing number. And this solution is pretty simple to do, and the time complexity would be big O of n, because we are just simply running two for loops separately. So we are not doing much work in terms of time complexity. And for the space complexity, other than storing the value for just couple of parameters, we are not consuming any additional space. So the space complexity would be constant. And this is an optimal approach that we are asked as a follow-up in our original input. For the second optimal solution, we are going to use bit manipulation. And specifically, we are going to use XOR operator. So if you don't know what XOR operator is, let me give you a quick tutorial on what each value is being represented when it gets XORed with some other value. We can only have four possible values for A and B, because all the values in computer system are represented as binaries. Now in the XOR, if both values are 0, we consider the value as 0. If any one value is 1, we consider the A XOR B as 1. Same goes for this one. And if both values are 1, we again consider A XOR B as 0. Now, let's see that using this logic, how can we find the missing number? now consider this property that for any given value n, if we XOR n with itself, the answer we would get is actually 0. And let me show you what I mean by that. Suppose our current n is actually 6. And now let's represent this in binary. And now let's try to do n XOR n. And this is the symbol for XOR in in programming language. So if we do the result, uh, 0 0 is 0, 1 1 is 0, and 1 1 is again 0. So if we XOR two values together, the answer we get is actually 0. But if we XOR, so suppose if we XOR the values like 6 XOR 6 XOR 3, the answer we would get is actually the value by itself. So because 6 XOR 6 would be 0. And now let's try to XOR 3 with this given 0. So the binary representation for 3 is equal to 0 1 1. And now when we try to XOR these two values, 0 and 3, the answer we would get is 0 1 1, which again means 3, the number that we XORed 0 with. And we also notice one more additional property over here, that whenever we XOR two values, so 6 XOR 6 XOR 3 gives the result as 3. Also, if we change the order and if we put any order like 3 XOR 6 XOR 6, this will also result in 3. And if we do like 6 XOR 3 XOR 6, this will also result in the value 3. Because order doesn't matter. If we are XORing two values by itself, both are going to eliminate themselves and their answer would be 0. So whatever is remaining would be the answer of this one. And we can repeat this for whatever number of times you want. So we can, if we do something like uh, 2 XOR 3 XOR 2 XOR 6 XOR 6 XOR 7 XOR 7. If we run this entire thing, still the answer after this would be 3, because notice that over here 2 cancels itself, 6 cancels itself, and 7 cancels itself, and only 3 is going to be remained. So now since we have established all of this, let's try to see that how can this be useful for us in this given problem. The input for our given problem is actually we are given range and we are given the input number. So suppose for an example, the range we have is 0 to 4. So 0, 1, 2, 3. Let's consider it 0 to 3. And the input parameters we have is suppose 1, 3, and 0. So notice that number 2 is missing. Now, if we were to use this XOR logic, that if we XOR all the values in the range with all the values in the nums, we would get something like this: 0 XOR 1 XOR 2 XOR 3 for this range portion. And if we XOR this with the nums input, we will get 1 XOR 3 XOR 0. And if we combine both of these, basically all the values that are same would be eliminated and would be turned to 0. So this 0 would cancel out this 0, this 1 would cancel out this 1, and this 3 would cancel out this 3. And notice that right over here we just determine that the order in which XOR happens does not matter. Everything is not right next to each other, still they will cancel out each other, and at the end we are only going to be remained with the value that is not at all present in this nums input. So in the nums input we don't have the value number 2 present, so the result of range XOR nums would actually give us the value 2, and the result 2 we can simply return it, and this would be our solution. So this is a very neat, very unique solution. And because we have the knowledge of XOR, we are able to come up to this result. And if we use this in any interview, this clearly shows that you have very sound knowledge of computer concepts, and you know how to apply them when they seem fit. This would definitely give you a very extra, very sharp edge over all the other candidates. And let's do the complexity analysis. So for the time complexity, we are actually doing everything in just the single loop, for one loop for range and one loop for nums. So the time complexity would actually be big O of n, and the space complexity would actually be big O of 1, because we are not using any additional space. So this would be the most optimal solution, and this is what the problem is asking us to find. Now I showed two optimal solutions, but first optimal solution is very trivial to understand, so I'm not going to code it up, and I'm only going to code up this XOR solution.
So we will first of all create a variable XOR and we initialize it to 0. You can give any name. And now we will run a for loop starting from the range. So int I equal to 0 to I is less than or equal to nums dot length I plus plus. And every time we will XOR the number with itself. So now again we will run another loop, and this time we will run it for the given input array. Notice that we are only using I is less than number of length, and over here we are using less than or equal to, because in the range we have one value more than whatever the length of number is. And again we repeat the same operation, XOR with the value in the given input array. And now we will simply return whatever we found in XOR, that this would be our missing value. Let's try to run this code. Looks like our code is running. Let's try to submit it. And yeah, our solution works perfectly fine, and it's actually pretty fast and pretty efficient. And hope you like this video. I'll be posting the solution in the comments, and let me know if you have any suggestions for the videos. Yeah, let's clear FAANG together.
Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a lead code easy problem, reverse bits, and this has something to do with bit manipulation. So let's understand the problem statement. Basically, we are given a 32-bit unsigned integer and we need to reverse all the bits in it. Let's consider it by an example. Suppose the value we are given n is equal to 5, and if we represent it in binary, the binary representation would be, and since the given input is 32-bit, all the other bits would be 0. Now we just need to return a new element, reverse, that looks like the exact reversal of this binary value. So this would so the rightmost bit on the original input would be the leftmost bit on our new variable. So the value should look like 1, 0, 1, and all the remaining zeros, because this one is also 32-bit. So basically the rightmost zero would be at leftmost position in our new variable, and we need to return this. The problem statement is really easy to understand, and let's see that what could be the approaches we can take to solve this. In order to solve this problem, we are going to use bit manipulation, and specifically we are going to use two bit manipulation operators. First one is AND operator and second one is OR operator. And let me show you by truth table what each of these operations represent, and these are the symbols to represent them. So the possible value for A and B we could have is, so for A and B, if both the values are 1, then only we consider A and B as 1. Otherwise, if there exists a single 0, we will keep their value as 0. So this would be the table for A and B. And in A or B, if there exists a single 1, we would consider the value for A or B to be 1. So if both are 0, then only we would have A or B as 0. Otherwise, the value would always be 1. Now let me show you that how can using these two operators we can calculate our solution. We are only given one thing over here, the input parameter n, and suppose our n is 5, so the values would be like this. The new variable that we are trying to determine reverse is actually unknown to us, and that will have all the values that are in reverse order for the given n. And we know one thing, that all the values in given n is actually 32 bits, not more than that. So the first intuition is that if we run a loop 32 times, and every single time we take whatever element is present in n, and if we put it in our reverse variable, so whatever element we have present in our n, we put it in the reverse variable, and then we start shifting the reverse variable one step to the left side. So at the end of the loop, our reverse variable would be exact reverse of whatever value that is present in the given n. So let's determine that what would be our algorithm. Initial value for our reverse parameter would be 0. So the entire value would be, and when I say 0, I mean that all the 32 bits would be 0 for the reverse element. Now, at the beginning of, and we would run a loop from I equals to 0 to I equals to 32. And at the beginning of our loop, we would have a condition that every time we are going to left shift the value of reverse parameter to 1 bit. So at the end, we would have rotated any value that is present over here, we would have rotated it to 32 times, and it would end up on the leftmost position. After the rotation of the value, so first of all, so inside the loop, first of all, we will rotate 1 bit to the left, and we would represent it with this symbol. Next, what we are going to do is, somehow we will have to get whatever value of n is present. We need to copy that value for that particular element and somehow put it on the subsequent position at our reverse order. So how can we do it? And we know based on our and or operators, so at any given moment the possible value for n would be either 0 or 1, and we want to copy whatever value of n exists in our reverse parameter, a reverse variable. So if we do an n and 1 operation, then this would specify, and this would provide us with whatever value of n there exists. So suppose if the value of n exists as 0, and if we do an AND operation with 0 and 1, the result we would get is 0. If the value of n exists as 1, and if we do an operation 1 and 1, the value we would get is 1. So this is how we can get the exact value of 1 that is present, exact value of n that is present. And once we calculate this value, that n and 1, we need to put this value in our reverse variable. But the thing is, in our reverse variable, all the values are initially set it up to 0. So all the values are 0, and the potential value of n and 1 operation could be either 0 or it could be 1. And whatever we get over here, we need to transfer it to our reverse variable. And the way we can do it is, if we simply do whatever element is present at our reverse variable, and if we do an OR operation with whatever the answer we get from n and 1, we would be able to put the exact value that was present at n at any given moment. So the operation that we are going to do is, current value of reverse we have with, and we would be ORing that with n and 1. And suppose initially, so if the value of n is equal to 0, the answer after this operation would become 0, and we know that the value of reverse is initially set to 0. So we would be doing 0 or 0, and the answer we would get is 0, and we would shift it to our reverse. And at every single iteration, we are going to do a left shift on the reverse parameter. So whatever value we set up at the first, at the end of the 32 iterations, it would end up over here. And so we are taking care of the value of reverse parameter by shifting them one parameter left. But we also need to shift the values of given n one parameter, one bit to the right side, because we need to calculate every single value of n. So suppose the value of n is like 0, 1, and then bunch of zeros, and then 1. And this comes out to be the whole 32 bits. We need to calculate every single value of n that is present, and we need to put it in the reverse order. So at the beginning of our loop, we will calculate this value. We would put it in our reverse loop, and once that is done, this value would be stored over here initially in our reverse variable. But we know that we are doing a left shift operation on our reverse variable. So eventually the value will keep on transporting on the left side, and it would end up at the first position, which is what we want. But the thing is, on the n way, on the given input, we need to do a right shift operation. So we keep on eliminating the values that we have already calculated, and we are eventually, when we come to the end of the 32nd bit, we would come to this value. So 31st bit would become this value, and this value would be entered at the second position, reverse variable. So I hope this makes things clear. I know it's a little bit tricky to understand, but once you will do an example by yourself with this expression, that reverse, the value of reverse is actually the reverse we currently have, or n and 1. And after this, we would be able to copy whatever value of n we have to our reverse for that particular bit. And then it's just a matter of shifting the values of reverse on the left side and shifting the value of n on the right side. And at the end of the loop, we can simply return the value of reverse variable, and this would be our answer. So now let's calculate the time complexity for this approach. Basically, the time complexity would be big O of 1, because the only work we need to do is we need to run a for loop for 32 times, and that can be done in constant time. And even for the space complexity, we can complete the entire iteration in just constant time, because we are not using any additional data. We are just using a couple of parameters to store some values, and this would be a very fast solution, and it's really simple to understand. But the thing is, we need to come up with a little bit of logic, and we need to have a little bit of understanding of the bit manipulation operators. And now let's move on to coding.
So first of all, we will create a variable reverse and initialize it to 0. Now we will run a for loop. Inside the for loop, we will first of all do a left shift on reverse. Then we will apply our logic to calculate the value of n to reverse. So we will do reverse or with n and 1. And now we just do a right shift 1 bit for the variable n. And at the end of and after the loop we simply return the value of reverse. Let's try to run this code. Yeah, looks like our solution is working. Let's try to submit it. And yeah, our submission works actually 100% faster than all the other submissions, but this is not true. This is because the solution runs in the constant time. And hope you like the video. Let me know what kind of videos you want me to do next, and if you have any suggestions regarding my videos, feel free to let me know so I can improve upon them. Our aim is to clear the FAANG, and we are not going to stop till we clear FAANG interviews. Thank you. Bye.